Lesson number 1 for any production planner is to read The Goal by Eli Goldratt. So this video is really lesson 2. How to identify the bottlenecks in your own factory. In the following video, we explain how to easily identify bottlenecks using OptiPlanner software.
Bottleneck theory says that if you review your current workload against finite capacity constraints, you will identify bottleneck work centers in your plant, which restrict the speed of the throughput of the order flow. The objective is to identify these work centers and spread their workload, if possible, speed them up, or add more labor to them and optimize other workflow feeding into and out of them to maximize throughput. This increases the overall performance and reduces costs of the entire operation. This is absolutely fundamental to the profitability of your company. So how do we identify these bottlenecks? And do they change on a weekly basis? Since OptiPlanner already has a finite capacity calendar for each work center, you can see available capacity for each day. Once you have imported any new sales orders, you can now see the loadings on each work center daily, which need to be achieved to deliver all of your production on time. The first thing to do is review your first week's loadings against available capacity. You do that by clicking on this cumulative capacity button. See how it is showing you how many hours you need to work on each work center for a 7-day period, a 2-week period, and monthly. You already know the available work hours of each resource. If you've forgotten, just click this button to remind yourself. Now compare weekly demand with available capacity on each work center. The bottleneck work centers are easily identified as work centers with too many hours loading.
So there are various actions which you will need to take. You might plan some overtime on those work centers, or you might spread some of its workload to another machine by moving some jobs, like this, or reduce setup time by ganging similar jobs together.
OptiPlanner will assist by automatically smoothing all dependent work path steps into and out of the bottlenecks. The objective here is to make an achievable plan with a specific schedule for each work center for the coming week. If you simply cannot make everything on time, advise management and sales. Some tough calls might need to be made to increase overtime or push due dates for some jobs back by negotiating with clients. Perhaps you can offer the client a split delivery, some this week and the remainder later. Talk to the client about their requirements. Often clients are reasonably flexible about due dates and quantities if they are kept well informed. They get most upset about late deliveries they weren't told about. In today's tight supply chains and just-in-time practice, if your raw materials are late delivered, it has a knock-on effect right through the subsequent supply chain. Another option is to prioritize direct client orders over stock replenishment. Since stock forecasts are speculative in nature, they should take second priority to fixed, paid upfront orders. In a nutshell, orders should be prioritized by cash flow. Alternatively, you might find that this week is a quiet period where capacity exceeds demand. In this case, you should take the opportunity to slow production down and focus on maximum quality while you have the luxury to do so. There's no point rushing through all the work and then sitting around idle waiting. That won't reduce your costs. You should also consider scheduling in some preventative maintenance, cleaning, training, tasks which will allow your factory to maintain higher throughput when sales picks up again. So either way, bottleneck theory infers that you do reactive planning on a weekly basis. You need to review your workload and reschedule as necessary to target fastest throughput cycle time. This will maximize your company profitability and minimize your customer disappointments, just as it describes in the goal. Be always aware that any plan is best-case scenario. We can't fully predict the future. It is likely that next week's plan will still be inflated by some of the work we thought was going to get done this week. Because once you've set your plan, things can only get worse. Operators phone in sick, raw materials are faulty or don't turn up, machines break down, the wrong paperwork is used, scrap is high, quality mistakes are made, rush rework is required, a fire alarm goes off. By definition, unexpected implies infinite new possibilities. So all you can do is set an optimum plan, then manage that tightly, reacting as necessary to keep everything on target. Of course, these planning calculations are dependent on accurate run hours being set in the product recipes. Many companies find that the run hours calculations in their ERP system are not accurate enough for this purpose, which leaves them flying blind in terms of understanding true forward workload. One solution to this is to configure OptiPlanner's custom SQL formulas to calculate these correctly within OptiPlanner itself. In a further video, we will discuss how these run hours, labor, and raw materials allocations can be fine-tuned from the shop floor feedback loop to improve the quality of the plan.